You are listening to the Information Security Nonce Podcast, episode 51, originally released on March 31st, 2021. I'm your host, Josh Amishav. Today, Jim Manico joins the show to talk about cross-site scripting, implementing content security policies, or CSPs, password security, and more. My three main takeaways for our conversation were 1. How to do input validation correctly. 2. Why using Nonces in your CSP is safer than creating a allow list policy. And 3. How apps should store their passwords. Hint, it doesn't involve bcrypt. You'll enjoy those three things plus a bunch of other tips along the way. Direct support for this podcast comes from BreachSense. If you need visibility into your clients, employees, or third-party suppliers' breach credentials before criminals exploit them, then head on over to breachsense.io to apply for a free 7-day trial. And now, here's my conversation with Jim. Jim Manico, welcome to the show.
Great. How are you doing today, good sir? How are you doing, Josh?
Good, all good. Thanks for coming on. So, can you tell us a bit about who you are?
My name is Jim Manico. I'm the founder of Manicode Security, and I run an education firm, right? We do instructor-led training, primarily teaching software developers how to do software security.
Awesome. So I want to jump into cross-site scripting, and it's something that's been discussed ad nauseum at length before, but why is it still an issue in 2021?
It's a major issue because there's really no good way to store a secret in the browser. And if I can get XSS into an application, I can steal all the data, deface the site, force the user to do fraudulent transactions. It's a big deal. And because the web is so complicated in terms of the client, it's not easy to stop this. That's why we've had HTTP only cookies. We've talked about escaping. Then we talked about HTML sanitizing. Then we talked about secure use of JavaScript. Then we started talking about content security policy. And now the latest and greatest standard is trusted types. And it's still not solved because of how complicated the client is. And it's gonna be something we're gonna have to face years from now. It's not gonna go away.
So why, well, first of all, what are trusted types?
Trusted types is a new standard from Chris Christoph where I can set programmatic policies in the browser around individual JavaScript calls to limit or to add sanitizers to low-level JavaScript functions that don't typically have sanitizers or similar built in. Again, it's a way to programmatically essentially change how low-level functions in JavaScript works. And this is the work of Chris Christoph, part of Google, who's led the charge in the standard. And it's live in browsers today, even though it's still a relatively new technology.
Cool. Learned something new. So why is it like SQL injection was a common issue, and then we're able to solve it or solve a lot of it via frameworks? Why can't we use frameworks to solve cross-site scripting?
It's not going to happen because with SQL, it's not fair to compare SQL injection defense to XSS defense. They're totally different balls of wax because I can solve SQL injection in a fairly standard way. What is that way, Josh? Come on, Josh.
Parameterized queries.
Parameterized queries and variable binding. That's right, Josh. So, and that's essentially how the problem is solved. And there's some nuance around that, but it's really just parameterized queries. You teach developers that for 5 minutes, and they should be able to fix that problem. Now with XSS, let's get into it. If I want to display data exactly like the user typed it in, then I want to use escaping, but I have to use one of like 5 different escaping functions based on the location in the web page. So we haven't even gotten started yet, and already there's a multitude of defenses even for basic data being displayed. So what if I want to display HTML that a user submitted through like a WYSIWYG editor, and I now have to render that HTML? Well, you can't escape it anymore. Now you have to use an HTML sanitizer like DOM Purify. Okay, we're not done yet. Now, what if you're doing JavaScript programming and moving data around the DOM? Some of these, you have to be aware of which low-level JavaScript functions are safe and which ones are not. And sometimes you have to do, the real rule is use safe functions in JavaScript. Use safe syncs in JavaScript. But if you do need to use something like inner HTML, you want to use a tool like DOM Purify to do HTML sanitizing. All right, what if you want to embed JSON on the page itself? Then you want to use a JSON sanitizer instead, not a JSON sanitizer, I'm sorry, a JSON serializer or a JSON encoder. And the common technique is to use stringify functions to embed JSON, which is inherently unsafe. And by the way, if you're going to use like React, you have to avoid things like dangerously set inner HTML. And if you are going to use them, you want to make sure you use an HTML sanitizer. Or how about this? If you're using JSX in React and I want to render a URL like a user's homepage, I have to validate that URL to make sure it's not a JavaScript URL. Not one more, I'm still not even done, right? If I want to add untrusted data into a block of style, then I have to use CSS escaping. And if I'm doing this in JavaScript, the CSS escaping function that's native in ECMAScript doesn't work in IE 11, so I probably have to use a third-party JavaScript library to do CSS escaping. So you get it, Josh? If XSS defense was a Facebook relationship status, what would it be? What would it be, Josh?
It's complicated.
There you go.
Okay, so what are your thoughts on same-site cookies, HTTP only flags to help limit cross-site scripting?
So let's fix the question, right? Same-site cookies are not used to address XSS. Same-site cookies are used to address
cross-site request forgery, which you would use in a XSS attack to force a user to do something.
But you really wouldn't use same-site cookies to stop XSS. It's not the right defense, because if I get XSS into your browser, the code is executing as if I was the developer. So even if you had same-site strict cookies, my stored XSS attack would still fire a same-site cookie. So same-site cookies are strict or lax. That is for cross-site request forgery only. And so...
Well, what about reflected cross-site scripting?
Reflected cross-site scripting is also stopped with same-site cookies. The only issue is here's the nuance in same-site cookies. If I have a link that hits the browser to drive a request, then that will ship a lax cookie if the browser and the server are the same domain, but it won't ship a strict one. So I want to use a strict same-site cookie if I only want to trigger requests from the browser with the cookie, and I want to use lax if I want things like an affiliate link to fire off that cookie. But the same-site cookies are to stop cross-site request forgery, and any XSS will defeat that defense. Now, HTTP only in cookies is to stop JavaScript from reading the value out of a cookie. I say go ahead and use it, but it's not going to stop XSS, because my XSS can still force a forged request and leverage the cookie even if I can't steal it, even if it's a same-site cookie. If I get XSS in your browser and you have the best same-site cookie, it doesn't matter. I'm going to still be able to abuse your session management and force a request on behalf of that user through XSS. So yeah, XSS is hard. I think CSRF defense is easy, frankly. XSS defense is hard.
All right, so let's talk a bit about content security policies.
Right on.
Okay, first of all, how effective are they in stopping cross-site scripting attacks?
They're extremely effective if you're limiting what browser the user can use, because there's a lot of nuance in terms of browser support. Like CSP3 doesn't work well in Safari and IE. And if I want to use CSP level 2, I got pretty decent browser support at that point. And so if you are limiting what browsers the user can use, and you're using a policy that's specific to those browsers, and you're building your app from the ground up with CSP, it is massively beneficial. It can be hard to retrofit CSP into an existing complicated application. And I'll go one further. If you're using hundreds of JavaScript files to drive your client without any kind of reasonable limitation, there's no hope for you. You got to start by being sensible in how you're designing a web page. I see some websites that are using like 4 different versions of jQuery together, and that just hits a level of nonsense that I don't even want to help you to defend it at that point. You got to have a reasonable design to start with. But CSP, and I look at the work from Google, from Michel Spagnuolo and Lucas Weichelbaum by far, and frankly, Neil Matatal from GitHub. I like to combine the techniques of those 3 to set my own policy. Keep an eye on my website in the next couple of weeks. I'm rolling out like a 0 JavaScript site with a real strict policy. But if you're going to have a typical website, I recommend you focus on a noncing policy. And if you only use CSP3 level browsers, consider the strict dynamic. This is pretty easy to roll out. You nonce every single script that you need to use. And that is just such a strict policy, and it's extremely effective in stopping XSS if you're limiting your users to only modern browsers that support this. If you're going to support Netscape 3 or like Firefox 1, there's no hope for you. I can't defend those older browsers reasonably. And if you look at the W3C browser stats, not a lot of folks are using older browsers. And you probably want to block really old browsers anyways. They probably have other problems.
Wait, if you use the Nonce approach though, and your third-party JavaScript that you're bringing in is dynamic, so your nonce is going to change every time, then are there any other options?
Dynamic JavaScript is bad design, first of all, right? All your JavaScript should be static and using things like JSON to provide dynamic data. And even if the JavaScript is dynamic, though, strict dynamic allows for you to dynamically load other scripts in certain ways legally. And as long as the script blocks has the nonce value, even if that's dynamic JavaScript, it's still going to fire. The things that get problematic is when you have dependencies. Like if I load one library and that in itself loads many other libraries, right? That dependency tree in the world of JavaScript, that's a problem. And so if you're only using nonces, you have to nonce every single script that you need for that page. But if you're using strict dynamic on top of nonces, then any nonce script will have all of its dependencies load automatically. The problem with strict dynamic is, again, it's not going to work in IE 11. It's not even going to work in Safari. I'm going to check that. I got to check I'm going to go to can I use? I love can I use, and I'm going to say strict dynamic. So I can look, so Safari does not support strict dynamic for CSP level 3. And John Weilander, come on, John, get me some CSP 3. And every other browser supports it well, except for IE 11. And Josh, IE 11 doesn't count. IE 11 is a filthy, insecure piece of trash browser with poor modern security standards, and you should programmatically block that piece of filth to save your users. The problem is that's my opinion. And even though the W3C browser stats are now at 0% users are using IE 11 around the world statistically, there are some industries like medical that really depend on IE 11. And so I have a few customers that still need to use it. And guess what? You can't use strict dynamic reliably for IE 11. And that's what limits CSP. So this is why I say, if you can control the browsers the users are using, and you're only supporting modern browsers, IE 11, it's not a modern browser. It needs to go away. Edge supports CSP3 really well, right? Why does Edge do that? Because Edge uses Chromium under the hood now. That's beautiful. In my opinion, from a web security standard point of view, that's beautiful.
Can you explain the differences between CSP 1, 2, and 3?
CSP 1 is an allow list policy where I have to have a list of all the different places I'm hosting JavaScript, and it's gonna block the eval function. It's gonna block all inline script. So if you have a basic website with JavaScript and on your site only, and you're not doing any inline JavaScript, CSP1 is enough. In fact, if you're using a modest number of JavaScript files, and they're only hosted on your domain, you can do it in your policy script source self as the foundation of your policy. And for simple websites, that's super effective. And again, it blocks the eval function, it blocks inline script, it blocks any injected script that comes from third parties. That's a powerful policy. The reality is many websites are hosting JavaScript, are using JavaScript from a lot of different locations, or pulling scripts from this and that location, and they still do inline script as well. So that's why noncing is so important. If the now noncing is CSP level 2. At CSP level 2, every script block that I
What's that? Just explain. Nonce is essentially a checksum.
A nonce is not a checksum. A nonce is a random string that I'm going to add to script blocks as an attribute, basically. So it's got to be random. It's not a checksum. There's two ways to add this capability in CSP2. I can use either a hash or I can use a nonce. Nonce is better supported. I tend to use nonces, but I have to do random number generation at scale for every page. I have a random value in the CSP policy, Nonce, and then I have that same Nonce value in all of my script blocks. So they get permission to run. And any other script block that doesn't have a Nonce doesn't get to run. So now I can be really specific about what JavaScript runs in my site, and everything else is going to be denied by default. This is why.
But in that case, the nonce has to be within the JavaScript itself, right? So if I'm pulling in a third-party JavaScript I don't have control over, can I add a nonce to that?
Well, you would load that by saying like a script tag where the source is a path to that JavaScript file. And you'll have an attribute in that script tag that says nonce equals some random value that needs to match the response header. So when I start adding all these script blocks to third-party JavaScript, they're going to be nonced. It's just a random value as an attribute in the script tag that matches the nonce value in the response header. And this kind of noncing is the strongest way statistically to do CSP, supporting a big list of all the different paths where JavaScript can load from. Like 94% of those allow list policies are bypassable, according to research from Spagnuolo and Weichelbaum and others. So I recommend a pure CSP policy. And I also recommend go watch a presentation called Making CSP Great Again. If you don't like that title, that's the name of it. That's from 2016 presentation. I'm sorry if I'm offending anyone in that title. It's not my intention. I'm just a technician. And there's also a 2021 presentation, I believe, on modern web security standards. And the presenters are, again, Michel Spagnuolo or Lucas Weichelbaum from Google. They got the best research on how to roll out CSP. I also like what Neil Matatal taught me about starting your policy with default sources none to turn everything off by default and then add little by little what you do need.
So then how do you end up not like when you implement a WAF, very often you start in a detection only mode, and you never actually pull the plug to put it in prevention mode because you're afraid to stop traffic. When you're implementing a CSP, how do you get to a position where you can flip the switch and start enforcing the policy?
Good QA program, right? Build a good policy and test it rigorously. I don't know what else to say. Like there are all kinds of tools that you can use to automate quality assurance, to make sure you're not breaking anything. You want to do this in a wide variety of browsers. It does take really good QA to make sure you could roll out CSP successfully.
When you add CSP, what's your approach? You add the none, then you see, you put in report only mode, you see all the reports, all the errors, and you just one by one just add them to the policy, or is that the right approach to creating a CSP?
I want someone building my policy who knows the standard really well. And I'm going to start by building that policy and deploy and do extensive QA and fine tune it in QA. Once I've gone through many QA iterations, so I know I'm not breaking anything, I will deploy it at first in report only mode and then monitor those reports for a couple weeks. And I hopefully don't need to tune my policy because it was built by someone who knows what they're doing. You can't just kind of flop around with this. This is such a precise standard. You got to do your research and homework before you roll this stuff out. And once I've done QA for a bit in report only mode, and I've done my own QA in production and see that nothing's broken, and I do this in a variety of different browsers that I support, then I can shift to a block mode. If you don't know CSP and you're kind of just playing with it and you're doing it in a kind of sloppy way, I mean, that's not how you roll these technologies out. So before I would even talk about it, I did a lot of homework, watched a lot of presentations, read the standard several times, and I still make mistakes. It's just a really difficult standard. So you got to do your homework first before you roll it out. Remember, Dr. Strange, what does it take? It takes study and practice, and a lot of both to achieve mastery over these technologies.
So I'm just wondering if I misunderstood the Nonce approach. If you nonce a third-party script, and then that third-party script becomes compromised, would you have any indication that it became compromised?
No, because you nonce that script, you're assuming that script has decent security properties. So if there's like a vulnerability in the script itself, and that's now live on your site, you can still have XSS through some of that dynamic code. Absolutely. So it behooves you as well to keep your third-party libraries up to date in addition to rolling out CSP. So this is complicated. And I got to tell you, my inclination is to really minimize my use of third-party frameworks and third-party JavaScript and be real surgical and minimal around what I'm going to use so I can control the security of it. Again, Josh, if you're just using hundreds of different JavaScript files, there's only so much we can do to help you at that point. And that kind of insane design, I think, needs to go away. And we need to be judicious about the technologies we're using to build websites.
Cool. Okay, now I want to change subjects a bit to passwords. You recently tweeted, passwordless authentication always depends on something that is protected by a password. Can you elaborate on what you mean by that?
Nick Mason in Pink Floyd was quoted as saying, I was really drunk at the time. I may have been imbibing a little bit late at night, and that's like a troll kind of comment, because I knew it would trigger a lot of people because there's so much investment in the world of password-less security. And overall, I really have a lot of disdain for how passwordless security marketing is done. I don't think a lot of it is unfair. I'm not going to point the fingers at specific companies. I will say this, though, in the positive, are you an iOS user? Are you a cell phone user by any chance? I know that my cell phone is basically my multi-factor device, and I authenticate with biometrics. And that if someone can get into my phone with my biometrics, if someone can get into my phone, that's a pretty big hit for me. I have a lot of important information and a lot of apps that are already logged in underneath my cell phone authentication. The point I'm trying to make, though, and I'm kind of stealing this from Daniel Miessler from Apple, right? And his point was, even though I may use phone passwordless authentication with biometrics, well, I authenticate it with the standard passcode in the first place. So all I'm saying is, and I do mean this, that even though passwordless security has its place, it's emerging as an important potential for authentication and identity, so much of passwordless authentication is tied to some other form of authentication, which is password-based. And so we're a ways away from having a passwordless world, in my opinion. Passwords still matter, and they have their place, and it's something easy on consumers. And if you look at the work of Jim Fenton and NIST Special Publication 663, this is the federal government digital media guidelines. I mean, they really want to put the work on password verification, not on the user, but on the processor and the verifier of passwords. And I think as developers who are building identity systems, we have to do more work to make passwords more secure and not expect users to do that. And passwordless authentication, yeah, it's got its place, but it's not going to replace what we're doing now anytime soon.
2030, will we still have passwords?
Absolutely. I'll bet $1. Anyone who wants to bet, and here's the thing. Here's the irony. If I go back 15 years, I made a bet with a lot of security people that passwords would go away. We'd have multi-factor. I was totally wrong. I give up. I failed on that bet. So passwords will still be a part of the identity ecosystem a decade from now. Absolutely. I think multi-factor will be much more the norm in addition to passwords.
Okay, so let's talk a bit about password policies and storing passwords. When you look at various web apps, there's so many differences between password policies being implemented. How should you do that correctly?
Password policy? I recommend you look to the guidance of NIST Special Publication 863. This is the biggest standard change in password policy we've seen in a generation. This is the work of Jim Fenton and a whole team at NIST who wrote this standard. And they're addressing things like credential stuffing, suggesting you block common passwords, the top 50 to 150,000 common passwords that would typically fit your policy. Now block those. Also, 8-character passwords or longer is the standard. And that may seem low, but they're also saying as soon as sensitive data is part of the picture, you should be using multi-factor, and there's no excuse not to. So passwords by themselves, according to NIST SP 863, is for public data, and a lot of folks violate this. And the point is, again, it's 2021. Passwords by themselves as a sole factor is not acceptable security. So most systems should have multi-factor. And I know a lot of industries don't do that yet, and I think that's a very big problem. So when NIST special publication 863, when they say 8-character passwords or longer, you got to put it in context. It's like for public data, who cares? And for truly sensitive data and other similar risks beyond public data, of course we should be doing multi-factor. And so with that in mind, 8-character passwords are just fine statistically.
It's interesting because the ASPS specifies 12, but they don't do the.
Oh, I changed it.
You changed it?
Oh yeah, go look at Maine right now. It's back to 8 because that's the real NIST standard. It was there at 12, and the other project leaders may argue with me on that. We may have a little, but like right now, I'm the main active lead who's managing GitHub for 4.0.3. I'm certain when Andrew Vanderstock, who put it in there in the first place, Josh Grossman and Daniel Cuthbert see what I have done. I merged that PR right in. They may have words with me on that. But again, the point is, 8-character passwords are just fine if combined with a multi-factor element, according to the risk. If it's AAL level 2, primarily sensitive data, then you should have SMS and a stronger factor if you're going to use SMS. Like, let me try that one more time. You should have multi-factor. A lot of folks say don't use SMS. SMS for multi-factor at AAL level 2 in SP 863, is acceptable if you're also offering another stronger form of multi-factor. And if you're at AAL level 3, you want to use hard tokens like YubiKey type technology and similar. But again, anytime you have sensitive data, you should have multi-factor in play, or at least make it available to the user. And a lot of sites just don't even offer it at all. And that's a problem, in my opinion.
Let's talk a bit about the ASPS. Before we get into what is the ASPS?
It's the Application Security Verification Standard. It's a 3-tiered standard of developer security requirements around building secure software.
Okay, and how is it different than the top 10?
Top 10 is an awareness list for a security conference. It's not a standard. It's popular, but in a lot of ways, I dismiss the OWASP top 10 other than a 1-hour conference talk to get people aware of what software security is. And it's not a standard, nor should it be cited as a standard, nor should it be used as a standard. It should be read once and discarded, and then spend all of your time focused on the ASVS, the Application Security Verification Standard. Because application security, Josh, is complicated. It's full of extremely deep nuance. And ASVS is like 300 or so detailed requirements that web developers need to embrace to write secure software. And there's 3 tiers for 3 different levels of severity. You can start at level 1 and work your way up based on how risky your software is.
So now in the ASPS, now that you lowered the password requirements to 8, there was another requirement for multi-factor, for supporting multi-factor authentication. If you had a low-risk application without sensitive data, should you require the application to support MFA?
I don't think so. According to NIST SP 863B, I believe, they make it very clear in their authenticator choice that if it's only public, when you say low risk, that's public data only. That's data. It's nothing sensitive and nothing private. It's like public data that you want a user to log into for accountability purposes. So the only real low risk software, according to NIST standards, is public data. And so a lot of people say it's low risk when it's really not. If there's private or sensitive data in there, it's already AAL level 2. If the loss of that private or sensitive data is a risk, then multi-factor should be in play. Absolutely.
That's a very important nuance. All right, let's. If somebody wants to get into information security, what resources? Where would you recommend they go?
Study and practice. Study and practice. I mean, a lot of people want a quick fix. How do I get into security? Here's the question I get a lot, Josh. It's how do I get into security without doing a lot of work? And I'm like, I can't help you. It's study and work, reading standards, getting and just practicing. I think if you want to get into application security, you really should learn how to code if you don't already. And I'm not saying it to be a full-on software engineer, but knowing some basics around JavaScript, HTML, SQL, and spending some time understanding the challenges of writing software is fundamental to application security careers. And if you don't know how to code but want to get into application security, I would start there. Go take a little boot camp on building a web app. Go through some of the free education resources that are on the web around using certain languages. But again, if you want to get into application security, it's going to benefit your career significantly if you have experience writing software. So I'll start there.
So let's talk a bit about password storage. How should apps store their passwords?
I recommend they use Argon 2 ID and take a look at the password storage cheat sheet. I'm going to bring this up and cite some of it right now because I've rewritten it in the last couple of weeks, and I'm kind of being get bad. Like I went into the password storage cheat sheet. I'm back to being like active on the project every day, and I got a few of the Hashcat team members to assist me with this, and I don't even know Steve. He goes by like Scoob on Twitter. He's one of the leads of Hashcat. And Jeremy Gosney, also a Hashcat team member, said, Jim, listen to him. He's one of the most gifted intellects that we have in the Hashcat and password cracking community. So doing real world testing, I can now say, like, you should use Argon 2 ID with a minimum configuration of 15 megabytes of memory, an iteration count of 2, and 1 degree of parallelism. If Argon 2 ID is not available, then use bcrypt with a work factor of 10 or more with a password limit of 64 characters because of bcrypt's truncation. Don't do your own pre-hashing. That's not the right path. It's problematic. Just limit passwords to 64 characters and bcrypt's truncation problem goes away. And if you're already using scrypt,
wait, doesn't that go against the ASPS? At least previous versions of ASPS said there shouldn't be any upper limit on password length.
It is. In order to use bcrypt securely, you have to break the ASPS standard. And I'm okay with that because you shouldn't be using bcrypt anymore unless it's legacy. We have Argon 2 ID, which won the password hashing competition. So the go-to should be Argon 2 ID with the minimum config of 15 megs, iteration count of 2, and 1 degree of parallelism. That should be your go-to algorithm. Bcrypt should not be the choice for new websites anymore. And if you are going to use bcrypt, the simplest way to get around the truncation problem of bcrypt is to limit 64 characters. And that's in conflict with ASPS, but that's what the math says, right? And that's what the easiest way to use bcrypt safely. Other recommendations are to pre-hash, but if you pre-hash before using bcrypt, that's going to add other vulnerabilities into your site that I'll talk about in a moment. If you're using scrypt, you want to use a minimum CPU parameter of 2 to the 16th power, minimum block size of 8, and a parallelism parameter of 1. And if you need to do FIPS 140 compliance, like federal government systems, you want to use PBKDF2 with a work factor of 310,000 or more and an internal hash function of HMAC SHA-256. Also, consider a pepper. Consider doing an encryption round and then store the hash from the core algorithms encrypted before you store it in the database. And I can't say it enough. Like a lot of the advice that we've given around the use of bcrypt is just really not good advice. You want to avoid the whole pre-hashing problems because there's what's this issue again? I don't have the word in my mind. I'm gonna look it up. Yeah, something called password shucking. Where it adds, I'm not going to discuss shucking. It's something that's still new to me. I was just convinced it's a real risk. You should talk to some of the Hashcat team members to get deeper into that. But a lot of the advice on bcrypt does add a weakness, which makes it much quicker to crack it. So you can basically strip out the bcrypt defense if you see a hash match between accounts from different breaches across different sites. So go take a look, Josh, at the password storage cheat sheet. I spent a lot of time working on this with some of the best password crackers and experts in the world on this topic. And there are a lot of like armchair experts in password storage, like myself. And I'm citing the research of other experts. This is not my brain or my expertise. I'm just the writer who took the advice from all the other real experts and sorted through it and got their approval before I pushed this stuff live. So I guess, I want to go beyond my knowledge and actually look at real world data to make good security decisions. And that's why this cheat sheet has gone through so many changes recently. So take a look at it. The password storage cheat sheet at OWASP. And there's 5 bullet points at the top that summarize the advice that you should be taking as a developer. And I stand by that.
Awesome. Yeah, I'll link that up in the show notes. All right, to finish up, do you have any advice for someone starting their own security company?
Study and practice, a lot of hard work. Do not think you're going to get away with a 40-hour week. To be a business owner, it takes a lot of extra work. And I don't think you should be starting a business unless you have good sales and paperwork capability, because that's a lot of the business, especially up front, is being able to generate business, being able to do effective marketing, being able to be a good solution provider, do your own accounting, or at least handle the paperwork part. There's a lot of minutia that goes with running a business. And if you're not willing to do those things, then I think you're better off as an employee or a consultant as opposed to a business owner. So I start the morning by doing paperwork, invoicing, and a lot of non-security things. That's part of being a business owner. Josh, I like that stuff. I like running a business. I'm a little obsessive compulsive. I like the details of life. So having my business dialed in well is something I'm okay with. And I know a lot of technicians who are not okay with that. So don't do a business then. And just because you get just because someone gives you millions in funding and you hire people to do that, well, now you're a manager. And a lot of technicians don't want to do that. I like to do a lot of the things myself or hire individuals to do it and work with them on it. But I'm just saying there's a lot of non-technical work that goes with running a business. And if you don't like doing that, then don't run a business. Work for someone else who's okay with all that non-technical minutia. That's my advice in that area.
Awesome. It's always good to hear advice from an entrepreneur. Thank you so much for coming on the show.
Absolutely my pleasure, Josh.
All right, that's it for this week. If you have any comments or questions, then tweet at me at Jamoose. And if you got value from this episode, then please share it with a friend. See y'all next week.